So, NVIDIA's GTC 2026. Look, this wasn't just your typical tech conference, not by a long shot. It was more like a peek into a future that's being powered by this brand new, really revolutionary idea, the AI factory. So, let's dive in and break down what that even means and why it's probably going to change, well, everything.
And, NVIDIA's CEO, Jensen Huang, he really didn't hold back. This quote right here, it basically set the entire tone for the whole event. We've moved way beyond just talking about faster chips. This is something else. We're talking about a massive shift, a complete change in how our economy works, where intelligence, it's not something you just develop anymore. It's something you manufacture.
So what's the product being made in this new factory? Well, it's all powered by this thing called Agentic AI. And you got to understand, this is a huge leap past the chatbots we're used to. Think about it. These aren't just answering questions. We're talking about autonomous systems that can actually reason, plan, and then go and do complex things, all on their own, in both the digital and, the physical world. No hand-holding required.
Okay, so if you're going to build these kinds of advanced AI agents, and you want to do it at a massive scale, you can't just use the old tools. You need a whole new kind of production line. And that's where this idea comes in. Welcome to the AI factory.
And the core idea here, it's actually pretty profound when you think about it. For decades, right, computers were all about one thing, processing data that we, humans, created. The AI factory, it completely flips that script. Its whole purpose is to take in raw data and energy and spit out a brand new commodity, tokens of intelligence. And to do that, you basically have to reinvent the computer from the ground up.
So what's under the hood of one of these AI factories? What's the engine look like? All right, let's get into the really groundbreaking new hardware that NVIDIA just pulled the curtain back on.
Okay, so it's not just one single chip. It's this tightly integrated team of three, and they call it the Vera Rubin Platform. And it's really best to think of them as a specialist crew. You've got the new Vera CPU, that's the orchestrator, the one calling the shots. Then you've got the Rubin GPU, that's your heavy compute engine, just raw muscle. And then there's a brand new player on the team, the Groq LPU, which is all about lightning-fast, real-time response.
For the longest time, the CPU is kind of a sidekick to the big, powerful GPU. Well, not anymore. This new custom Olympus chip, it's like the foreman of the whole AI factory. It's the brains of the operation, handling all that fast, step-by-step reasoning and planning that these new agents absolutely need to work. And that memory bandwidth you see? It's just insane, and it's totally crucial for juggling all those complex tasks in real time.
But of course, the Vera CPU isn't a solo act. It's got its team. It's paired up with the Rubin GPU. That's the heavyweight champion, the one that can handle these massive trillion-parameter models. And then there's the Groq LPU. It's a total specialist that NVIDIA brought in to do one job and one job only: deliver answers almost instantly. That's the secret sauce that makes an AI agent feel, snappy and responsive, not laggy.
So, you might be asking, how in the world do they get that kind of speed? Well, it comes down to this really clever new method they call asymmetric split inference. And the best way to picture it is like a super high-tech assembly line. The big Rubin GPU is like this giant industrial press, doing all the heavy lifting up front, stamping out the main structure of the answer. Then the Groq LPU swoops in like a bunch of super-fast robotic arms, just rapidly adding all the finishing touches, every single word or token. And when you divide up the work like that, the result is a mind-blowing 35x increase in throughput. That's not just an improvement. That is a total game-changer for how efficient AI can be.
Okay, but let's be real. All this world-class hardware, it's just an expensive pile of silicon if you don't have the software to make it sing. So now let's look at how all this hardware plugs into a full-stack operating system designed for the entire AI factory.
So the whole factory is built on three main pillars. First, you've got networking. We're talking unbelievably fast Spectrum-6 Ethernet to just firehose data around. Second, a totally new storage platform they're calling CMX. And this is cool, it creates a shared context memory. This is a huge deal because it solves what they call the context grind problem. It means agents can actually remember long conversations without having to reread everything from the start every single time. Big boost for speed and efficiency. And then the third pillar, the actual software to manage the agents themselves.
And Jensen Huang had a great way of putting it. He said OpenClaw is the Windows moment for these new agentic computers. And that analogy is perfect, right? Just like Windows gave all our PCs a common language to run software, OpenClaw gives these AI agents a standard environment so they can find their way around, use different tools, and actually get work done on their own.
And of course, for businesses, they've built this whole enterprise-ready stack right on top of that foundation. You've got NemoClaw, which adds all the crucial security and governance stuff you'd expect. Then there's OpenShell, which is basically a secure sandbox to make sure the agents don't go poking around where they shouldn't. And my favorite part, AIQ, which is like a smart traffic cop that looks at a task and sends it to the best, most cost-effective model for the job. And get this, it can cut query costs by 50%. That is huge.
All right, so let's recap. We've put together the factory, we've installed this insanely powerful new engine, we've even booted up the operating system. The production line is fired up and humming. So, what is it actually making? What are the first products rolling off this revolutionary assembly line? Let's take a look.
And really, that question, how far can this new intelligence go, drove the whole second half of the keynote. And the answer, well, it's pretty wild. And it starts in a place you would probably never guess.
So they put up this number 25x, a 25-fold increase in compute performance. I mean, that is a gigantic leap. But 25 times more than what and for where? Let me give you a hint. It is not for a data center down here on Earth.
That's right, in space. The new Space One Vera Rubin module delivers 25 times more AI compute for data centers in orbit. What this means is we can now have real-time planetary intelligence. You can process all that satellite data right up there, at the source, instead of having to beam it all the way back down to Earth and wait. It's incredible.
And it's not just happening up in orbit. The applications are popping up everywhere. There's a new foundation model for humanoid robots called Groot, a brand new safety OS for self-driving cars called Halos. In healthcare, you've got giants like Eli Lilly building their own AI factory, a LilyPod, to speed up drug discovery. And in the creative world, Adobe's putting this power into Firefly. And gamers, get ready for DLSS 5 to bring real-time, movie-quality lighting to games.
Okay, so let's pull back for a second and look at the big picture. What does all of this actually mean for the future? Because NVIDIA didn't just show off a bunch of cool tech. They laid out a whole economic blueprint for what comes next.
And here's the absolute key takeaway. We are officially entering what they call the token economy. Intelligence itself, the stuff being pumped out by these AI factories, is now a product, a commodity. And just like any other utility you use, think electricity or water, it's going to be sold with different price tiers based on how much performance you need. What's great about this model is that it makes AI accessible to pretty much everyone. It doesn't matter if you're just one person with a simple task or a massive company running something mission-critical. This tiered pricing means you only have to pay for the exact level of intelligence and speed that you actually need. No more, no less. And listen, this isn't just a one-and-done thing. NVIDIA put up a very clear, very aggressive roadmap. We had Blackwell in 2024. Now we know about Vera Rubin for 2026, and they even teased the next one for 2028, Feynman. This 2-year rhythm, this cadence, it's a massive signal to the entire tech world that the pace of innovation isn't slowing down. If anything, it's speeding up.
So, when all was said and done, GTC 2026 gave us this incredible vision of the future. But it also left us with a really big question to think about. We now have the blueprint. We know how to build factories that can literally manufacture intelligence at an industrial scale. The hardware is ready, the software is booting up. So the only real question left is, what are we, as humanity, going to choose to build with it?